T minus 1 minute. T minus 50 seconds. T minus 40 seconds. T minus 30 seconds. T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Good day to all of you, my dear fellow students, and here we are once again, and I welcome you back on our fourth day in our virtual immersion training program here in STI West Negros University under the College of Engineering. So, are you still ready? Are you still up for more knowledge, informations, and are you still excited and interested of what engineering has to offer to you? Well, here's our first topic for today, which is AutoCAD.
Hello everyone, I am Juan Paulo Nacion.
And my name is Adrian Dayan.
And we will teach you about basic AutoCAD. Okay. What is AutoCAD? So AutoCAD, or computer aided design, it allows to draw and edit digital 2D and 3D design for more quickly and easily. It is used by mostly architects, drafters, and even engineers in order to design blueprints for bridges, buildings, and roads. For example, sa mechanical engineer, ginagamit ang CAD para mag-design mga motor parts, sa electrical para mag-map out ng electrical system, sa chem engineer para sa plant design nila, kag sa civil engineer naman mga floor plan and structural design. So, this is the first thing you'll see pag open mo sa AutoCAD. We have here Get Started, Present Documents, and Notifications. In order makasugod ka na gi-drawing, you click Start Drawing. Okay, amo na niya sulod sa AutoCAD wherein sa tunga ng model space, sa babaw mga commands, and sa right side ang navigation. So first, on the upper left, we have here the application button or application menu. If you click this, makita mo di ang new, open, save, save as, import, and so on. The function of these buttons are very similar lang gid sa Microsoft Word. Na kung mag-obra ka mo essays nyo and etc., makita nyo lang na di. Next, sa tupad ka up button, ang Quick Access Toolbar. From the name itself, this toolbar contains most of the frequently used tools from the application button. That's the reason why makita nyo man di ang mga save, open, and print nga logo. Sa dalawang naman is ang ribbon area. It contains all the tools and commands properly arranged into different tabs and panels. Ang sa draw nga column, makita mo din different commands like lines, circle, polyline, and arc. For the modify, we have here move, rotate, cut, and other editing tools nga makapahapo sa aton mag-drawing. In annotation, it includes dimension, notes, and other types of explanatory symbols. Next is the layer. Medyo advanced na ni siya nga tools. So let's move on. Makita taman di ang info bar, which is you can type the name of any command or tool to get more information about it. Next, we have here the navigation bar. Dito nyo makita ang pan, zoom, and orbit. For the pan, amo na siya kung gusto nyo i-move ang inyong workspace. Simply click here, then drag your mouse. Or pwede man gamiton ang inyong scroll button sa inyong mouse. I-hold nyo lang kag i-drag. Next is the zoom. May mga settings man di nga kung wala kong mouse dire nyo lang pinduton. Pero if may ara, i-zoom, mag-zoom in, i-scroll up nyo lang and scroll down para mag-zoom up. And last, orbit. It is useful gid kung 3D na inyong mga i-drawing on. In the lower part, we have here the status toggle bar, which contains of tools such as grid, on and off. Kung gusto nyo na wala mga square ni bala sa inyong workspace, click mo lang ni, then wala na. If gusto nyo may ara, click nyo lang ni luwat. Next, the snap mode. Sa snap mode, makabulig nito select precise points like midpoint and endpoint. Sa piyak na side, we have here UCS or User Coordinate System. It shows the X and Y coordinates. And next, layout tabs are like sheets of your drawing. Bali daw ka next page naman isang inyong drawingan. If we want to change or to set the units of your measurement, just type unit, then enter. Aman siyang magwa. Tapos sa dire pili lang ta sang aton nga unit na gusto.
Hi guys, and once again my name is Adrian Diane, and I will now teach you the basic commands on the AutoCAD. So to start with, I will teach you on how to use the line. So in order to use the line, you just have to press this button on the upper left corner of the screen and then select your first point and the second point to make a line. And you can also make different figures or shapes depending on how you want it. And to stop using the line tool or the line command, you just have to press the escape button on the keyboard just like this. And by the way guys, the shortcut on making a line is just by pressing the letter L on the keyboard just like this. And then press enter. And there you have it, you can make a line. And the next thing that I wanna teach you is how to delete or erase some lines or figures. Just like this. First, you just have to highlight the figures or lines that you want to delete. Or you can also select the lines one by one, and then after you are done selecting the lines that you want to delete, you just have to press the delete button on the keyboard. And the next thing that I want to show you is if you accidentally deleted the files, or I mean the figures or lines that you are working on, you can still get it back just by pressing OOPS or oops, and then press enter, and there you have again your previous work. So the next thing that I want to show you guys is how to use the polyline or the pline. So first you just have to click this button and then pick your first point again, and so on and so forth until you reach the figure that you want to make. And by the way guys, the shortcut on using the pline command is just by pressing PL on the keyboard and then press enter, and there you can use the polyline command. And some of you guys might be thinking that the polyline and the polyline and the lines are just the same, but they are not, and you will see the difference between them later. So moving on to the next one, I want to show you guys on how to use the offset command on AutoCAD. So in order to use the offset, you just have first to press letter O on the keyboard and then press enter, and here I must have to put a specific distance for my offset, and I will just select 1 meter for the offset distance. And here you will see the difference between the polyline and the line as I will put the offset. As I put the offset on the polyline, the whole figure will be affected, while on the line only one side of the figure will be affected, just like this. And also on this one. And the next thing that I want to show you guys is how to use or make a circle. So in order to make a circle, you just have to click this button first and then pick a specific point that will act as a center for your circle, and then drag the mouse wherever you want and you will see the circle. And if you are already satisfied with the size of your circle, you just have to click the left click button on your mouse again, and there you have your circle. And there are also two ways on making a circle. It is by using the radius and the diameter, and right now I want to show you how to use the radius on making a circle. And first I want to show you the shortcut on the circle command. It is just by pressing letter C on the keyboard and then enter, and I will pick a specific point again that will act as a center for my circle. And right now it is showing that I must have to put a specific radius for the circle, and here I will choose 15 for the radius of my circle and then press enter, and there you have it, the circle that has a radius of 15 meters. So the next one will be how to make an arc. So first you just have to click this button and then pick 2 points where you want to put the arc, and you will see the arc now, and you can customize the angle and the size of your arc. And as you can see, there is an angle on the right side of the cursor, and it is with respect to the x-axis. And if you are already satisfied with the arc that you have, you just have to press the left click again on the mouse, and there you have an arc. So the last basic command that I will teach you guys is how to use the trim command. And in order to use it, you just have first to type TR on the keyboard and then press enter. And from there you just have to select the lines that you want to remove, just like this. You can also remove the excess lines that you don't want anymore, just like this. And there you have it. You already know how to use the trim command. So let's now move on how to make a floor plan. Okay guys, so going forward, I will now teach you how to make a floor plan. And our floor plan will have an area of 64 square meters. First, we will use this polyline command, and then we will make a box which will have 8 meters by sides on each sides, just like this. And to close this line, I will just press C and enter, just like that. and the standard thickness of the walls will be 0.15 meters. So I will put an offset, just press letter O and then enter, and I will put 0.15 meters for the offset, just like that. We will now put divisions on our floor plan, and right here I will put the toilet and bathroom, which will have an area of 1.5 by 2.55 meters, just like this. I will put 1.5 and then enter, and then 2.55 meters and close it. And then for the rooms I will put 2.5 by 4 meters. So from here I will put 2.5, and then I will put 4 meters, 2.5 again, and then close it. So this room will have the same size as the room that I will put here, so it will be 2.5 also by 4 meters. So first I will put 4 meters, enter, then 2.5, and then close. I will now show you guys how to put an offset on these lines, and these lines will serve as center of your walls, and I will put 0.075 meters of offset on each side of this wall, which is half of the standard thickness of the walls, which is 0.15 meters. Let me show you. So I will put offset 0.075, enter, and I will put it both sides. And then from there I can already delete the lines on the center of the wall. Just select the lines that you want to delete, and then press delete on the keyboard, just like that. And I will close these lines. Just put a line here, and then there you go. I will now erase or remove the lines using the trim command. So first you have again to type TR on the keyboard, press enter, and select the lines that you want to trim, just like this. So the next thing that I will put here, guys, are the doors. So the doors, or the main doors, have a standard width of 0.9 meters, and for the rooms, the doors have a standard width of 0.8 meters, and for the bathrooms you can just put 0.7 meters for the width. So let us now start making a door, and to show you how to make a door, you can just use the line command, just like this. And I will make a door for the main door, so it will have 0.9 meters of width, and I will put that 0.075 thickness for the walls or for the doors. And then to make an arc, just press this button on the upper left corner of the screen and then choose the points where you want to put the arc, just like this. Next thing that we will add are the windows. Already done with the layout of our floor plan, and the next thing that we will put are the interiors of this floor plan. On this part, guys, I am already done with making the bed and other interiors for the rooms, and also I am done already with the interiors for the toilet and bathroom. The next thing that I will do is the interiors for the dining area and the kitchen area. On this part, I am now done with making the interiors for the kitchen area and the dining area. And the next or the last thing that I will do is the interiors for the living area. So we are now done with the interiors for the floor plan, and the last thing that we will have to put are the dimensions of this floor plan. And to put dimensions on this floor plan, guys, you just have to click this button and then choose the side that you want to put the dimensions. First, I will pick this point and then this point, and after that just drag the mouse away from the floor plan, and there you go, you have already your dimensions. And the finished product of my floor plan or my layout is this one. So here is the 8 meters by 8 meter dimension for the whole floor plan, and for the kitchen and or the toilet and bathroom, it has 1.50 meters by 2.55 meters. For this room, we have 2.5 meters by 4.0 meters, and the same as this room. And for the living area, we have 3.6 meters by 4 meters. And last but not the least, the kitchen area and the dining area, we have 4.4 meters by 4 meters. And there you have the final layout for the floor plan.
Well, I hope you've learned a lot about AutoCAD and you've understood how helpful for our work in today's society to make our works faster and easier with AutoCAD. So next up, we will have the topic surveying.
Good day, everyone. So at this moment, our topic is about surveying. So in civil engineering, one of our subjects is surveying. Before, sa old curriculum, it is surveying 1 and 2, but because of the senior high school, it was changed to surveying only. So allow me to share this quote with you. Below the roads, run the surveyor's line, which squared off the wilderness, and not only made it ready for sale, but constructed a shape for country and state government. It is from Andrew Peter. So later on, you will realize why he said this quote. So let's proceed to the introduction to surveying. What is surveying? So surveying is the art of determining the relative positions of different objects on the surface and below the surface of the earth by measuring the horizontal and vertical distances between them and by preparing a map to any suitable scale. Thus, in discipline, the measurements are taken in the horizontal plane alone. So, what is the objective of surveying? The aim of surveying is to prepare a plan or map to show the relative positions of the objects on the surface of the earth. We also have here the uses of surveying. To prepare a cadastral map showing the boundaries of fields, houses, and other properties. To prepare an engineering map showing the details of engineering works such as roads, railways, reservoirs, irrigation canals, and etc. For the best example here is your houses, lot in your houses and subdivisions, wherein the surveyors play a very big part, wherein they are the ones nga gapangita kung di lang asta ang inyong lote and di lang asta ang pwede ninyo nga mabutangan sa fence. And then so next, we have the classification of surveying. Generally, surveying is divided into two major categories, the plain and the geodetic surveying. So, what is plain surveying? This is used to designate survey work in which the distances or areas involved are small enough that the curvature of the earth can be disregarded without significant error. We also have geodetic surveying. It is the process of surveying in which the shape and the size of the earth are considered. This type of survey is suited for large areas, long lines, and is used to find the precise location for basic points needed for establishing control for other surveys. So, base and purpose, surveying has been also classified into control surveying, which is to establish horizontal and vertical positions of control points. Second is the land surveying, to determine the boundaries and areas of parcels of land, also known as property survey, boundary survey, or cadastral survey. I know, amo na siyang pinaka na familiar naton is the land surveying. Example is the lot sa houses naton, sa mga subdivisions. Just like what I have said earlier, amo na yung ginagamit nila to determine kung diin lang asta or din lang boundaries ang inyong area. So we also have next the topographic survey to prepare a plan map of a region which includes natural as well as man-made features including elevations. Next, engineering survey to collect requisite data for planning, design, and execution of engineering projects. We also have the route survey, which is to plan, design, and laying out of routes such as highways, railways, canals, pipelines, and other linear projects. We also have construction surveys, which are required for establishment of points, lines, grades, and for stacking out engineering works after the plans have been prepared and the structural design has been done. We also have astronomic surveys to determine the latitude, longitude of the observation station, and the azimuth of a line through observation station from astronomical observation. We also have mine surveys, which is to carry out surveying specific for open cast and underground mining purposes. So I have seen this meme for quite a while in social media, and the question is why? Why kuno nga pwede lang man siya straight, nga aging pa-curve siya? So just like what I have said kagina, we also have to respect the natural curve of the earth. Atong hinambag kagina sa plane surveying. So this is the answer to that question. So the vertical curves are used to provide a gradual change from one road slope to another so that vehicles may smoothly navigate grade changes as they travel, of course, para ma-avoid ang mga sudden accidents. And for example, just like sa mga bukid, some ginakwestiyon na nila why kuno ang alagyan is gapatiyog-tiyog. So, of course, kung ang bukid, straight ang dalan, syempre, pila ka meters ng takla dun sa salakyan, yung masyagan, yung makalambot ka mo sa babaw. Which is very impossible. That's why, ang purpose na, and of course, to respect the natural curve of the earth. So, we have next, the corrections in chain surveying. So, chain surveying is the simplest method of surveying. It is the exercise of physically measuring horizontal distances. In this method, the length of the lines marked on the field are measured, while the details are measured by offsets and ties from the line. So we have first the tape corrections. Precise measurement of distance is made by means of steel tape, 30 meters or 50 meters in length. Before use, it is desirable to ascertain its actual length, which is the absolute length, by comparing it with the standard of known length, which can be done for a small fee by the Survey and Standards Department. We also have the correction for absolute length. It is the usual practice to express the absolute length of the tape as its nominal or designated length plus or minus a correction. The correction for the measured length is given by the formula CA is equal to LC over I, wherein CA is the correction for absolute length and L is the measured length of a line. I is the nominal length of the tape and C is the correction to a tape. So we also have the correction for temperature. So did you know that steels expands and go back to its normal size, or gagamay siya or gadako siya? Example of that is sa mga ang ginagyan before sang train nga steels. Ang mga steels na wala na siya gadikit-dikit, they also have their gaps in between. So it is your assignment to research what is the reason why it expands and it go back to its normal size. So okay, next, the correction for the temperature. So it is necessary to apply this correction since the length of the tape is increased as its temperature is raised, and consequently the measured distance is too small. It is given by the formula C sub T is equals to A multiplied to the mean temperature subtracted by the standard temperature and multiplied to its length, or your L. So the sign of the correction is plus or minus according to as your mean temperature is greater or less than your standard temperature. The coefficient of expansion for steel varies 10.6 times 10 raised to negative 6 to 12.2 times 10 raised to negative 6 per degree, and that for invar from 5.4 to 10 times 10 raised to negative 7 to 7.2 times 10 raised to negative 7. So we also have here correction for pull or tension. The correction is necessary when the pull used during measurement is different from that at which the tape is standardized. It is given by the formula C sub P is equals to P minus P sub O multiplied by L over AE, wherein your CP or your C sub P is the correction for pull in meters, your P is the pull applied during measurements in newtons, your P sub O is the pull under which the tape is standardized, and the unit is newtons. L is the measured length in meters, A is the cross-sectional area of the tape in square centimeters, and E is the modulus of elasticity of the steel. So we have here our example number 1. So the problem is a line was measured with a steel tape which is exactly 30 meters long and at 18 degrees Celsius and found to be 452.343 meters. The temperature during measurement was 32 degrees Celsius. Find the true length of this line. The coefficient of expansion of the tape per degree Celsius is 0.0000117. So temperature correction per tape length is equals to your C sub T with the formula A multiplied to your T sub M minus T sub O multiplied to your small letter L or I. So here we have your small letter L there or I is equals to 30 meters. T sub O is 18 degrees Celsius. And your T sub M is equals to 32 degrees Celsius. And your A is equals to 0.0000117. So the length of the tape is at 32 degrees Celsius, which is equals to 30 plus your C sub T. So you have your C sub T, which is equals to 0.004914 meters. And then your total length now is 30.004914 meters. So now the true length of a line can be acquired through your recently acquired L over the length and its measured length, which is 30.004914 divided by 30 times your 452.343, which is equal to 452.417 meter. So that is now your true length. You also have here example number 2. So a line was measured with a steel tape, which was exactly 30 meters at 18 degrees Celsius in a pull of 50 newtons, and the measured length was 459.242 meters. Temperature during measurement was 28 degrees Celsius, and the pull applied was 100 newtons. The tape was uniformly supported during the measurement. Find the true length of the line if the cross-sectional area of the tape was 0.02 centimeters squared per degree Celsius, which is 0.0000117, and the modulus of elasticity is equals to 21 times 10 raised to 6 Newton per centimeter squared. So we have the correction per tape length is equals to A times your T sub M minus T sub O times your L. Given there, your A is equals to 0.0000117 times your 28 minus 18 multiplied by 30. So you have 0.00351 meters. So your sagging correction is 0. The pull correction per tape length is equals to your P sub M minus P sub O, which is your pull, multiplied by your length and divided by your AE. You have there your 100 newtons subtracted by 50 newtons multiplied to 30 divided by 0.02 times 21 times 10 raised to 6. So you have 0.00357 meter. In order to get the value of the combined correction, you'll have 0.00351 plus 0.00357 meter, which is equal to 0.00708 meter. To get the true length of the tape, you have here given 30.00708 meters. So to get the true length of the line, you have your true length of the tape divided by your 30 times 459.242, which is now the true length of your line is 459.350 meters. So our last topic for this surveying is the transit. So we have here the parts of a transit. We have the telescope and the locking levers, which is used to hold lenses, magnifying objects in sights. We have the detachable sunshade, used to block sunlight from affecting objects being sighted. We also have the graduated leveling vial, used to level the telescope on its base. So we have here on the other side is the sample picture of a transit. We also have the horizontal clamp screw, which holds the instrument in horizontal position when tightened. The horizontal tangent screw can be adjusted to make the instrument to move left or right on the horizontal plane. We also have the graduated vertical circle, marked by degrees, used for setting and reading vertical angles. We also have vertical vernier scale, which moves around the main scale, determining vertical angular readings that are too small to read on the main scale. We also have leveling screw, allows adjustment to be made to ensure the instrument is level in all positions. The base graduated leveling vial. The area level attached to tripod has a spirit level, ensuring base is level when attaching transit level. Focusing knob can be turned to make objects appear crisp and clear. So we also have the eyepiece located at the viewing end of the telescope. It can be turned to bring the crosshairs into focus. We also have the alidade, the entire upper part of level, including telescope, and supports leveling vials, spindle, and circle reading devices. This transit is mostly used sa pag-identify sang elevation and the leveling of sang mga duta. I cannot perform the actual using of transit level. I have here video, and I hope you will watch it so that you will be able to know how transit is and how to set up a transit level.
Good afternoon, my name is Art Sines, and this is a video on how to set up a transit level. First of all, I would like to thank Pro Castillo and Do Cross Construction for lending me the equipment that I have here in front of me in order to do this. So first of all, this is our transit level. The nomenclature of transit level is real simple. This is the eyepiece. This is your directional finder. On this side you have your focusing knobs, and down here you have your leveling knobs. If you look here, there is a leveling bubble, and the idea is once you set this up, to place that bubble inside the black circle. Okay. This is our tripod. Tripods come in two different types. They come in wood and aluminum. This one is aluminum. This is our grade stick, and this is the instrument that we use in order to measure our measurements and let us know exactly where we're at from the actual positioning of our transit level to what we are going to measure. This is a torpedo level, and our torpedo level sometimes sits on top of our tripod. As you can notice here, there is a bubble that goes there as well, and the idea is to get the bubble in between the circles for your tripod to make sure the tripod is level for the base. Okay, so for our first job is to get our tripod out. You notice the latches here on the sides. This is where we extend the tripod out so we can put our level on and put our base. We lock the position, levels in base, and we set it in front of us. Okay. We place our level on top of there to pretty much get it level as possibly can. We do that by lifting and raising one side to another. And if you can tell from here, our tripod is now level. You go with corrections. You notice the bubbles in between the black lines. That means our level base is level, which makes it easier for our tripod. We then take our transit level and we affix it to the bottom of the base of the transit level and the base of the tripod with the screw here, the affixing screw here. So we place it on top, pretty much match the pattern that's on there, and we tighten it down. Okay, the idea is to set the level at a eye level base so you don't have to go over up on your tippy toes so you can get a better reading. Okay. So but seeing how I'm shorter and I can't see the level, I have to bring it down a little bit. Again, I'll take my tripod, my level here, and make sure that we're level. And we are. Okay. The next thing we do is that we come over here to the level itself, and with the screws we move the level around, and that pretty much will get us level. So now that you have your tripod level, you turn it as such to make sure that your bubble is still in the center, which it is. The next part of this video is where we do our actual measurement. And this is done by taking the grade rod, extending it out. Usually the first three would be good. And holding it. Now this is a two-man process. One that's going to read the readings, and the other one's going to hold it. So if I was to come over here, and I was trying to shoot the grade, I would have an assistant help me by holding this grade rod. Now hold the grade rod for me, please, ma'am. My camera, the lovely Miss Sissy Signs, my wife. Now through here, on top there is a directional level. If you look through it, you can guarantee where your level is at. With your focusing screw, you bring it in to where you can pretty much see where you're at. There are crosshairs in between in the eye level. And the way this reads, that the transit level itself will come here with the crosshairs, and wherever you're at is your reading. Now, a grade rod is measured in tenths. The feet are the same. So in the red are the feet. In the black are the tenths, and in the small hash marks are hundredths. If you come in focus a little bit closer, you see on the bottom and top of the hash marks, those are hundredths. And you read it, so you would read, if you crosshairs would hit here, it would be 3 feet, tenths, and hundredths. So it would be 31, 1. So it would be 3 feet 11 is what you would read on that. The idea to do this is very simple. You place your level, your transit level where you're at. You rate your grade rod where it is affixed. You take that number plus the number that is already marked on a grade stick, which surveyors would come out beforehand and do, and you add those two numbers. This gives you the actual height of your transit. Now let's say we're going to measure a building that would be on the other side. You would turn this to the side. You would shoot where the grade rod would be at your building or your other grade stick, and that would be what your measurement is minus the actual height of your transit level, and it will give you your actual reading. And then from there you can determine whether you need to dig down, make a fill, or make a cut, or leave it as it is. That's pretty much it. There's not much else. It's really kind of simple with a lot of practice, especially leveling your transit out. Anybody can do this. It's not rocket science. The addition and the formulas that you use are simple as well. I hope this video helps. I hope it's simple enough that everybody can understand. If you have any questions, please feel free to leave any comments in my box if I could have done something better. And with that, I'll say thank you. And again, thank you to Perfil, Castillo, and Ducross Construction for lending me the equipment to do this.
Thank you so much, everyone, and I hope you learned something about surveying, and I hope to see you enrolled in Bachelor of Science in Civil Engineering at STI West Negros University. God bless you all.
And that's it for surveying. Last but not the least, are you still there? Okay, so last but not the least is our heat transfer. So brace yourself for the last topic.
Hi everyone, I'm Christian C. Oksanya, a third-year mechanical engineering student here at STI West Negros University. Today we will discuss about heat transfer. So what is thermodynamics and heat transfer? Heat is the form of energy that can be transferred from one system to another as a result of temperature difference. Thermodynamics is concerned with the amount of heat transfer as a system undergoes a process from one equilibrium state to another. Heat transfer deals with the determination of the rates of such energy transfers as well as variation of temperature. Heat can be transferred in three different modes: conduction, convection, and radiation. So we can see in figure 1-1 we have a thermos bottle with the hot coffee and an insulation. In figure 1-2, a hot coffee with 70 degrees Celsius with a cold environment with 20 degrees Celsius. Kinetic theory treats molecules as tiny balls that are in motion and thus possess kinetic energy. Heat is the energy associated with the random motion of atoms and molecules. Caloric theory, it is a fluid-like substance called the caloric that is massless, colorless, odorless, and tasteless substance. Energy can exist in numerous forms such as thermal, mechanical, kinetic, potential, electrical, magnetic, chemical, and nuclear. Their sum constitutes the total energy, E, or E in a unit mass basis of a system. The sum of all microscopic forms of energy is called the internal energy of a system. Internal energy may be viewed as the sum of the kinetic and potential energies of the molecules. Sensible heat, the kinetic energy of the molecules. Latent heat, the internal energy associated with the phase of a system. Chemical bond energy, the internal energy associated with the atomic bonds in a molecule. Nuclear energy, the internal energy associated with the bonds within the nucleus of the atom itself. Conduction is the transfer of energy from the more energetic particles of substance to the adjacent less energetic ones. In gases and liquids, conduction is due to the collisions and diffusions of the molecules. In solids, it is due to the combination of vibration of the molecules in a lattice and the energy transport by free electrons. The equation in the rate of heat conduction is equal to K times A times temperature 1 minus temperature 2 over delta X, or change in X. It is known also as negative K times A times the change in temperature over 2 change of X, where X is equals to thickness. We have the Fourier's law of heat conduction, and thermal conductivity K is a measure of the ability of a material to conduct heat. Temperature gradient dt over dx, the slope of the temperature curve on a Tx diagram. The negative sign in the equation ensures that heat transfer in the positive x direction is a positive quantity. Thermal conductivity is the rate of heat transfer through a unit thickness of the material per unit area per unit temperature difference. We have the given table of the thermal conductivities of some materials at room temperature. This is the range of thermal conductivity of various materials at room temperature. The thermal conductivities of gases, such as air, vary by a factor of 10 raised to 4 from those of pure metals such as copper. In Table 1-2, this is shown the thermal conductivity of an alloy is usually much lower than the thermal conductivity of either metal of which it is composed. In the Table 1-3, this is the thermal conductivities of materials vary with temperature. And this is the chart of the variation of the thermal conductivity of various solids, liquids, and gases with temperature. Thermal diffusivity is specific heat is joule per kilogram degree Celsius. It is the heat capacity per unit mass. Heat capacity is joule per cubic meter degrees Celsius. Heat capacity per unit volume. And thermal diffusivity is meter squared per second. It is represents how fast heat diffuses through a material. So this is the equation and the thermal diffusivity. It equal to heat conduction over heat storage. The larger the thermal diffusivity, the faster the propagation of heat into the medium. Convection is the mode of energy transfer between a solid surface and the adjacent liquid or gas that is in motion, and it involves in the combined effects of conduction and fluid motion. We have two types of convection. We have forced convection. If the fluid is forced to flow over the surface by external means such as a fan, pump, or the wind. Second is the natural or free convection. If the fluid motion is caused by buoyancy forces that are induced by density difference due to the variation of temperature in the fluid. We have the equation of Newton's law of cooling. We have the rate of heat convection equals to convection heat transfer coefficient times the surface area times the surface temperature minus the temperature of the fluid. This is the typical values of convection heat transfer coefficient. We have the type of convection and the heat transfer coefficient. Radiation. Radiation is the energy emitted by matter in the form of electromagnetic waves or photons as a result of the changes in the electronic configurations of the atoms or molecules. In heat transfer studies, we are interested in thermal radiation, which is the form of radiation emitted by bodies because of their temperature. Radiation is a volumetric phenomenon, and all solids, liquids, and gases emit, absorb, or transmit radiation to varying degrees. However, radiation is usually considered to be a surface phenomenon for solids. We have the Stefan-Boltzmann law. We have the Stefan-Boltzmann constant. It is 5.670 times 10 raised to negative 8 watt per meter squared times Kelvin raised to 4. Black body is the idealized surface that emits radiation at the maximum rate. We have the equation in radiation emitted by real surface. Emissivity is a measure of how closely a surface approximates a black body, for which emissivity is equals to 1 of the surface. Emissivity is greater than or equal to 0 and less than or equal to 1. We have the table of emissivities of some materials at 300 Kelvin. Absorptivity is the fraction of the radiation energy incident on a surface that is absorbed by the surface. Kirchhoff's law is the emissivity and the absorptivity of a surface at a given temperature and wavelength are equal. We have the absorbed heat radiation equals to the absorptivity times the incident heat radiation. The absorption of radiation incident on an opaque surface of absorptivity. Net radiation heat transfer is the difference between the rates of radiation emitted by the surface and the radiation absorbed. We have the equation of the net radiation heat transfer, and the unit is in watt. When radiation and convection occur simultaneously between a surface and a gas, we have the equation in total heat radiation equals to combined heat transfer coefficient times the surface area times the surface temperature minus the temperature of a liquid. We have three equations down below. The two is the one is the total heat radiation and the other is the combined heat transfer coefficient. So this is some problem solving technique. Step 1 is problem statement. Step 2 is the schematic. Step 3 is the assumptions and approximations. Step 4 is the physical laws. Step 5 is the properties. Step 6 is the calculations. And step 7 is the reasoning, verification, and discussion. So this is the summary of our topics. And that's all. Thank you.